And we already talked about this in the geometry portion of this class when we found that on a number line, the distance can be represented as the absolute value of the difference of coordinates. And it didn't matter which order you wrote those coordinates, you'd take the difference and then their absolute value to get the actual distance. Okay, and so this is going to be set up in two different types of questions. Okay, one set of questions, they're just going to ask you to evaluate or express it. Okay, so if you wanted to use absolute values to express the distance between -3 and x, and the way that you would do that is your distance is simply going to equal the absolute value of, and just take the difference of these coordinates. So either -3 minus x, or absolute value of x minus a -3, which becomes an x plus 3. It doesn't matter which of these you use; they would both be acceptable answers. The other form that you might be asked to kind of apply this distance and absolute value relationship is to do the following. Use absolute value to express the following. Okay, so here it's asking you to express the distance from -3 to x is 10. Or actually, let me change that to be. All right, so here you're asked to express the relationship that the distance from -3 to x is more than 10. Okay, so when you're asked to do this kind of a problem, you're still going to use this relationship. Okay, however, you're going to follow these steps. Okay, step 1, determine which of the elements is your distance. Okay, and so when you look at this, you're always going to have 3 elements, so which are measurement values. So which of these 3 elements is your distance? So in this example, the distance from -3 to x is more than 10. Which one kind of represents the distance? -3 and x are represented on the number line. 10 is the actual distance. So you find what that is. So in this case, our distance is 10. Whatever your distance is, you're going to wind up just setting that alone on one side. And I'll always use the right side here. Okay, once you identify that, your next step is to apply this distance rule. To relate these remaining elements. Okay, so the remaining elements are going to be the coordinates. Right? So now we're looking at -3 and x. So when we look to that, we're going to take the absolute value of, again, either x minus a -3 or -3 minus x. It doesn't matter which way you put it. I'll usually write the x's first, or the variable first, if given the opportunity. Okay, and then the final step, after you equate those, or after you relate those pieces, you're then going to select the correct inequality. That's needed for that particular case. So here is more than 10. So in order for us to show that this relationship, that the distance from x to -3 is more than 10, does that mean it can be greater than 10 or less than 10? Has to be greater than. Can it equal 10? No, so it's just left in that form. And so this is how we would write our answer. Okay. All right, now a couple things here. On your, when you enter absolute value expressions online, there is a vertical bar key that you can use on the keyboard. If you look right above the Enter key, okay, so if you look at on your keyboard, you have the Enter key or Return, and the one right above it is backslash and probably what looks like a vertical bar with a break in between it. Okay, that is what you're going to be using. Okay, so if you hit Shift and then that button right above Enter, that will be your vertical bar key. So here you would enter this just as it appears online, but you would use that vertical bar key for those absolute value expressions. And now this differs from how you would enter it on the TI-89. Okay, so this is on the computer. On the TI-89, however, you've seen the vertical bar keys on the TI-89, right? We used those earlier in this chapter. That vertical bar key that's right next to the left of the 7 is called a width key. Okay, so the key with the vertical bar is a width key, not absolute value. Okay, so if you want to express absolute value on your calculator, you have to do one of two things. You either type it in words, ABS, parentheses. So here you would express this as x plus 3, close the parentheses, greater than 10. Okay, so ABS, and then put the entire expression that's in the absolute value inside those grouping symbols, inside the parentheses. Okay, so you can either type it yourself, just hit the alpha key, type A, the key related to the A, the B, the S. Okay, or you can locate it in the math catalog. And the math catalog is found by taking the second button and then hitting the number 5. Notice right above the 5 in blue it says math. That's going to open up a math catalog. Once you do that, you're then going to select number. And underneath number, I think it's the second thing that you can access under number. And that is the ABS. And so that'll pull that whole command down for you. Okay, so those are the two ways that you would need to go about doing it. And it differs. Whether it's on the computer when you enter it, you use the vertical bar key. On the TI-89, you can't. That has a different meaning. You have to use the command ABS. All right, so if we talk through the first ones, you're just setting it up in the absolute value notation. So the distance from x and negative 6, just absolute value of x minus a negative 6. And you could have also used negative 6 minus x in absolute value. So either of those forms would be okay. Again, I'll probably use the first form. All right. For b, you have absolute value of 2/3 minus a negative becomes a plus 1/2. Okay, this can be simplified. As you work to simplify it, you do want to combine your fractions, so you find a LCD, rewrite them each in terms of the same denominator. So between a 3 and a 2, the common factor is 6. So 2/3 is 4/6. 1/2 is 3/6. So when you combine those together, you get 7/6 in absolute values, which when you separate, apply the top rule, since it's a positive value, and you get 7/6 as your answer. All right, if we move on to C, C is the absolute value of 16 minus a negative, so plus 16, which simplifies to root 32, which again applies the top rule. It just comes out of the absolute value expression. And then finally, D, take the absolute value of y minus z. There is no need to simplify anything else. You could have reversed the terms as well. Either of those forms would work just fine. Okay, questions regarding that, writing the expressions to represent distance using absolute value? All right, so this brings us then to this last set of problems. to describe this distance here. So in solving this, first one, the distance between x and 5 is at most 6. So you have these three elements, these three values. Okay, one of them is a distance, the other two are coordinates. Which one is our distance? The distance is 6, so I'm going to separate the distance, put the other two inside absolute values, and then relate them with an inequality. So x minus 5, or 5 minus x, it doesn't matter which one I choose. I'm going to write the variable first here. And then is this distance here is at most 6. So can it be less than 6? Yeah, so it's a less than. Can it equal 6?
Yeah.
It's at most 6, so it can equal 6. So that would be your inequality. All right. B, same idea. You have three elements, 3y and 7. In each case, you should have all three elements. Find the one that's your distance. So the distance between two coordinates, 7 and y, so those are your coordinates, which means 3 is your distance. We're going to separate 3, put the absolute value of the difference of the other two coordinates on the other side. So again, I'm going to write my variable first, although I could have written 7 minus y. Either of those would be fine. And I know that this distance is greater than 3. So can it be more than 3? Yeah. Can it equal 3? No. So that would be your inequality. Okay, and then the final example, once again, you identify 6, 3, and z. You have these three elements. Which one is your distance? 6 is at most 3 units from z. So the two coordinates are 6 and z. So the distance itself is 3. So we're going to isolate the 3, put the other two coordinates inside absolute value and take their difference. So 6 minus z or z minus 6, either of those forms is okay. And it has to be, it says 6 is at most 3 units. So this expression is at most 3. So can it be less than 3? Yeah, as long as it's at most 3. So it can be fewer than that. Can it equal 3? Again, at most does include. And so this would be the inequality form of that description.